Hi, Yuri. To begin with, could you please introduce yourself to our SAF members?
Hi, Chris. I am Jiri Hulcr, Associate Professor of Forest Entomology at the University of Florida.
Great. Could you talk a little bit about your training and background and what your research tends to focus on these days?
My training goes really far back into the woods of Europe. I started as a young nerdy entomologist there, and that's where I got most of my entomological education before I got to any college. As a kid running through woods and ponds, but then I did my earlier education, college education in Czechia, and then I did a PhD there in the South Bohemia University, and I got another PhD at the University of Michigan, and then a couple of postdocs, one in Wisconsin, one in North Carolina. And since then, for about 10 years, I'm here in Florida.
Great, thanks. So today we'll be discussing the short film, The Myth of a European Forest Revealed by a Bark Beetle Apocalypse, which is directed by Yuri and filmed by Rob Nelson, which I will argue is well worth the 15-minute investment, and will make the YouTube link available in the Forestry Source. The film focuses on a single bark beetle species, the European spruce beetle, Ips typographus, primarily in Central Europe, and the large outbreaks that have occurred there in recent years. Yuri, recognizing that each bark beetle species exhibits unique life history, traits, and impacts, I'd be remiss if I didn't mention to our readers that bark beetles themselves are in fact a very large and diverse group that include more than 550 species here in North America alone. Can you speak some to the diversity that exists among bark beetle species and the roles that they play in our forests?
Oh, I love this. When people ask me something like, the bark beetle is eating my pines, and that word itself already triggers another question from me: which one? Because there are 6,000 species of them around the world, and a big outcome of our decade of research is that we can't really say they're the same. Every one of these species has its own life history. They have their own private lives. They have their own special relationship with tree hosts. You know, the great majority of bark beetles don't care about living trees. That is a pretty dangerous place to be. Very, very small fraction of their diversity has evolved the capacity to live inside living tree tissues. But those happen to be the ones that people care about. Those are the ones that compete with us for the same trees that we're interested in. And those include the notorious tree-killing bark beetles in the United States, as well as in Europe and Asia.
Great, thanks, Yuri. Yeah, I find it very interesting when you read some popular articles and they talk about the bark beetle as if there's one species, if not one individual, running around out there causing all these impacts. You mentioned that, you know, their bark beetles are very important here in North America, and we'll get to that in more detail in a moment. Obviously, also quite important in Europe. Just to put the European spruce beetle into perspective, how would you compare its impacts in Europe's forests to, for example, something like mountain pine beetle here in the Western United States or southern pine beetle in the Southern United States?
See, even the phrase bark beetle impact actually looks different depending on what perspective you're looking at it. You know, if you're a forester, it is a tremendous impact, and both types of beetles, the pine beetles in the Western and Southern US and the spruce beetle in Europe, are causing very similar damage. The damage comes about whenever you have dense stands, and especially if you turn up the heat, like during the latest years when later years when we have higher winter temperatures and summer droughts. So the principle of this impact is very similar, pretty much analogous between many of the Western US species and the European spruce beetle. Now, if you look into details, many of them are different, such as beetles, you know, that live in the lodgepole pine system. That whole system has a different dynamic than a ponderosa pine, for example, and certainly different than the spruce system in Europe. The reason why I said that it's important to consider the perspective is that if you look at it from a perspective of a forest ecology, the beetles suddenly take on a different role. And many people would say that in the natural forest dynamics, they're ecosystem engineers. They're really important in the natural cycles of renewal of the forest to prevent a completely homogeneous stance of something like lodgepole pine or the European spruce from taking over the landscape. So in that case, they're also very similar. Some people equate the bark beetles to slow fire. They can cause damage, but if applied within the natural dynamics, that damage is really more like a healthy disturbance that assures a diversification of the ecosystem. So again, it is damage from the forestry perspective, but it is a ecosystem engineering from an ecological perspective.
Great. To follow up on that, about a third of the way through the film, you stated, quote, instead of thinking of beetles as the cause of tree death, think of them as a symptom of tree condition. And while I agree, I might expand your comment a little bit to something like a symptom of environmental conditions. Can you go a little further and highlight some of the primary factors that are known to incite bark beetle outbreaks? And are there any real differences between what we observe in North America versus in Europe?
I agree. This is a very important question and a moment that I have to really keep explaining to people. Because in the film, we talk about the spruce bark beetle and the spruce forest in Europe. And they have been badly beaten by a series of very dry summers and by 100 or 200 years of very intense silviculture based on spruce monocultures. Now, that is a beetle buffet. When I present these observations somewhere like Florida, people tell me, well, look, we also have monoculture plantations here, and we're not having that much of a bark beetle problem. And so it really depends on where you are, but I would still say that the two factors work the same everywhere you are. It is the tree density and the environmental stress, these days primarily manifested by drought and heat. And that applies in Florida. That applies in California. Once you have conifers too close to one another, and once you deprive them of a little bit of water, the same thing happens no matter where you are. Bark beetles hit them.
Sure. Yeah. I mean, one way I like to explain it is that you set the stage for these large scale outbreaks when favorable weather or climatic conditions simply coincide with favorable vegetative conditions. And in many cases, that means large numbers of suitable hosts.
Yes, absolutely. And we can actually see that also on the level of tree now. I wish this was more studied. I'm sad that people the tree physiologists and entomologists aren't bigger friends, because I think this is where the frontier of our science happens, the interaction on the individual tree. But we do know now from a research done in places like Israel, for example, that we can already see if you put sensors on the tree, physiological sensors on the tree, such as perspiration sensors, or sensors of how the tree is pumping water on a circadian rhythm, you can see when the tree starts slowing down its metabolic processes, and a couple of months later, that tree gets hit by bark beetles. So this is a process that applies probably everywhere where conifers and weather collide. We just don't know the details yet.
Great. So a little bit related to that, and a lot of discussion in the film about monocultures. I found that very influential. About 3/4 of the way through the film, the narrator states monocultures are super risky, which I agree with. Can you explain why this tends to be the case for forest pests in general, not just in reference to bark beetles?
It's very easy for any organism to, if it has an ample supply of food, to multiply and multiply and multiply. That is the very basic explanation. Now, an intriguing explanation that we're just finding out now is that the very density of trees also changes the way air travels through the stand. And if air stops, it's much easier for the beetles to find the next sick tree or the next tree that has been colonized by bark beetles, and they are releasing attractive pheromones. And we know this from a collaboration between forest entomologists and physicists, because we know now how the odors travel through the air in the forest. And we know that if we thin out a forest, there's a lot of turbulence and the beetles are having hard times finding the trees. But if the forest is really dense, it's very easy for them to find the next tree.
Yeah, I mean, in reference to monocultures, when you think about bark beetles in general, their job is to get from one tree to the next tree as quickly as possible to limit the amount of risk they encounter between those two trees. In monocultures, it obviously just makes their job a heck of a lot easier.
The most dangerous part of a bark beetle life is the flight. They don't want to fly. And I'm often asked by risk analysts and other people, how far can a bark beetle fly? And I'm saying, I don't think that's a question that has an easy answer. I can tell you bark beetles like to fly as little as possible. And exactly, Chris, like you said, if they have the tree a couple of yards away, that's way better for them than if the next tree over is not a conifer but a broadleaf tree. Then they have to start really searching.
Great. So again, about halfway through the film, the narrator said, asked this question: do we have to plan for the end of forests in the future? And I think many of our SAF members will find that question striking and perhaps somewhat concerning. But I'm really interested in your thoughts. Given climate projections, are there areas or perhaps even forest types that we should start to think about as no longer managing as forests? For example, perhaps allowing them to transition to other states.
That's exactly what our film is about. No, we're not worried about the end of forests, and I hope that we ended up on a sufficiently optimistic note. In fact, even in Europe, in the post-apocalyptic landscapes, forest is coming back with such a force you can't stop it. In fact, in most places, if people leave, what you get pretty quickly is afforestation. The trees will not stop. What people are concerned about is that there are going to be different types of forests than the ones we're used to. And especially those aren't going to be the easily manageable forests. And so that's why we have included that important section about the transitioning of a monoculture-based silviculture into more selective logging type of silviculture. And we figured out, well, we didn't figure out, but the people before us, the foresters before us who tinkered with different styles of silviculture figured out that that system can actually be both sustainable and make more money. Because you don't have to wait for the end of the stand to be ready for a harvest and then you make money. You know, in the Southeast US, that would be 20, 30 years. In Europe, that's 80 or 100 years. If a forest, it has been transitioned into a close to nature silviculture, you keep taking trees every year and you keep taking the best trees, and you don't have to worry about planting, because in that kind of tree, in that kind of system, the trees plant themselves and take care of the seedlings.
Yeah, I kind of wonder here in the West, for example, where we have such strong ecotones, that, you know, if you look at the projections of some of our future climates, for example, at very low elevations where now we have pinyon juniper growing, I'm wondering in the future if those types of areas will be able to sustain something like pinyon juniper in the future. And if not, do we consider allowing some of those to transition to something like sage steppe? And just something we're starting to kind of discuss more frequently.
There certainly are places around the world where I am worried about the end of forests, yes, where there's just not enough water. Trees will be replaced by savannas. This is why savannas are out there in the first place. But for the most part, like in Europe, I'm not concerned about the end of forest at all. It's just I'm concerned about people not really being ready to accept that their forest will have to look a little bit different.
Yeah, that's an excellent point. Very important. And not only that the forest will look different, that in some cases it may not be able to provide the same suite of ecological goods and services that we've come to expect over time, but that those will be reduced somewhere else.
Absolutely.
Moving on here, your film largely focuses on diversifying Norway spruce forests and reducing the density of Norway spruce, the host of the European spruce beetle, to increase resilience. What roles have off-site plantings played in recent outbreaks? My understanding is that many of the recent European spruce beetle outbreaks have occurred in areas where Norway spruce was planted off-site, or in areas where it is native but occurred at much lower densities than it does today.
That is the very basis of the outbreak. You're absolutely correct. In the great majority of the landscape in that part of the world, in Central Europe, spruce would have created monocultures only at the tops of mountains. Anywhere lower you go, it would have been admixed with fir and beech, and further lower you go, it turns into an oakland and much more diverse woodlands. But spruce is an incredible timber. It grows fast, it's straight like almost no other trees in the world. It is so easy to manage. It doesn't have any special soil requirements. It's really a fantastic tree. So I'm not surprised that the entire timber industry has transitioned over the past couple of hundred years to plant spruce. Now, the off-site planting issues, that's nothing new. You know, we're sort of rediscovering the wheel here, but even the old forest scientists knew that off-site planting of spruce is asking for trouble. This is nothing new. We're just seeing outbreaks on the scale that we've never seen before. But foresters have always been saying that this is dangerous. This is not a very safe investment. It's just that those foresters who have been saying that, and forest entomologists who have been saying that, have not really been the mainstream. But the facts are clear. You know, I think the bigger problem here is that we're not discovering any new science. Foresters everywhere in the world know that off-site planting is asking for trouble. The problem is that people often don't make decisions based on facts or evidence. People make decisions based on what they would like to believe and what their cohort believes and what their environment believes. People make decisions based on tradition. And if we start a tradition of a spruce monoculture that dominates forestry, that is a very powerful tradition that produces new generations of students and professionals. And that is the hard part. Changing the tradition, changing the perspective on our landscape.
Sure. Your film focuses a lot on what I might call indirect control or prevention. Are there other tactics available to manage bark beetle infestations and to reduce associated levels of tree mortality other than what has been highlighted in the film?
Yeah, the direct control of a beetle is very difficult. People use all kinds of sophisticated devices like pheromone traps, pheromone-baited logs, pheromone-baited and insecticidal sprayed logs, pheromone-infested nets over the log sites. You get a lot of beetles that way, unquestionably. But you can only get so far if you are working in a heat-stressed, overly dense monoculture. If this is an example of an herbivore, the bark beetle, where that is controlled by the supply of food. It is not really easily controlled by other forces if it's in the outbreaking stage. If it's in the endemic stage, that's a whole different matter. Endemic meaning if there is no outbreak, the trees are reasonably healthy and the beetles are certainly flying around. They're not uncommon, but they're not in an outbreak mode. In that stage, they are controlled by an endless array of other organisms and other forces, whether that's predators or parasites, or winters, or or rainy springs. The endemic, and so this is what we are going for. We are trying to replicate the ecosystem that maintains the bark beetles in the endemic stage, where we don't really have to control them. Because if you provide them the environment for an epidemic stage, all these sophisticated controls together aren't catching up.
So, Yuri, for our audience, when you say endemic, you're generally talking about a condition where the European spruce beetle in those types of stands may kill a tree or two every hectare every year, something like that would be considered
In the
endemic?
endemic situation, the European spruce beetle behaves like most other bark beetles, which is that they attack stressed or dead trees. They are very happy boring into a dead tree, even branches or roots, much happier than boring into a live tree. The behavior when they start boring into living and especially healthy trees is really a result of their population density. That's when there is no other tree to bore that's sufficiently weak. Like I said at the beginning, attacking a living tree is a very dangerous thing for beetles. And almost all the ones that start boring into a living tree die. So there has to be lots and lots and lots of beetles in the area for this epidemic dynamics to sustain itself.
Yeah, it's very interesting. We've looked at that a little bit with Western pine beetle in ponderosa pine here in California, and just depending on the physiological condition of an individual tree, it may take several orders of magnitude difference in the number of beetles actually required to kill that one individual tree, just simply based on how healthy it is.
And you just hit on one other important aspect, the diversity of tree defense. Because in a forest where trees are primarily reproducing by seeds, there is a huge variation in their response to bark beetles. There are trees that produce almost no resin. There are trees that produce enormous amount of resin as a response to attack. If you plant plantations, you usually deal with a very homogeneous genetic stock. And often in Europe, we don't even know where these spruce trees came from 100 years ago that we're harvesting now, or they're being killed now. We don't know if they came from seedlings from that area and how much resin they produce in response to beetles. They may have come from a different country, different region entirely. We have no idea whether the plantings were done with the foresight that one day these trees will have to defend themselves against bark beetles, and they are very homogeneous.
I think you and I both would agree that evidence suggests that bark beetle outbreaks are being exacerbated by climate change due to shifts in temperature and precipitation that influence not only their hosts, which is very well described in your film, but also the beetles themselves, other community associates in the system. Do you feel that current management approaches, which are largely based on research and development executed in the mid-20th to late 20th century, are they sufficient to meet the demands imposed by altered forest and climatic conditions today without some modification or adaptation?
I'm all for modification or adaptation, but I would also say that there has been a lot of really good research done. I would say that most foresters don't really need to adapt to a totally different paradigms or totally different school of silviculture. We just need to accept that it's going to be hot and it's going to be unpredictable. Or in some places, it might not be hot. It might just rain more. Or in some places, it might not even change very much, like in Florida. What is really important is be brave enough and look into the future's face, really. Imagine what the weather looked like 50 years ago and notice the changes until now and predict those changes. You don't have to look at models, although that's helpful, but just, quite honestly to yourself, predict yourself what kind of weather our trees are going to be living in 50 years from now. That is what I think foresters have to do, to be honest with themselves and say, well, things are going to be different. So let's look at the best evidence we have. And we have plenty of it that advises our silviculture today. I'll give you an example. In New York, the southern pine beetle is called southern for a reason. It's because it's from the southeast US and Central America. Recently, the biggest outbreaks have not been in the south. They've been in New York. And that's because the range of the beetle is shifting. So again, in the south, we know how to deal with this beetle. We know how to thin our forest, and the forestry here essentially is dictated by avoiding southern pine beetle outbreaks. Not so much in New York. But once our colleagues and we all learn that these boundaries of species are shifting north, that allows us to adopt new silviculture practices and predict what type of silviculture and what type of tree planting we need to do in these little more northern latitudes against some of these southern species, for example.
Yeah, that's a great example, particularly because in many of those cases, we also see their ecology shift a little bit. For example, in the Northeast on Long Island, the host is primarily pitch pine. That's quite different forest in terms of not only composition, but structure than they experience in the Southern US.
Yes.
Somewhat relatedly, and towards kind of wrapping this interview up, I reviewed some of the comments at the in reference to your film, and I noticed one of them that said, quote, "You might say that we're finally able to see the forest for the trees." And I really thought about that and kind of the message of your film. And I thought, well, it might actually be more appropriate to say something like, we can't see the forest for the trees. And of note, here in Western North America, where you're well aware, we've suffered some really severe and notable bark beetle outbreaks in different forest types in recent years. We're now seeing more and more evidence that in some of our forests, we may need to thin to lower densities than we've considered in the past to obtain similar levels of resilience to bark beetles, due again to those increases in host tree stress due to warming and in some cases, reductions in precipitation. And I thought that kind of story, which is very applicable here to the West in several of our different cover types with several different bark beetle species, aligned very nicely with the message that you were promoting in the film.
Thank you, and I agree with that. I would actually maybe say that we can see the disease for the symptoms. That we're so busy killing the beetle instead of looking into the core of what's causing these outbreaks.
Great, thanks, Jiri.